Up, guys? Today we're going to be going over elements of programming interviews in Python. This is a really good book that I've heard of that's been recommended a lot on YouTube. You've probably seen this too somewhere. Um, this was written by, I'm sure extensively, they might have had other collaborators by Adnan Aziz, Sung Sian Lee, and Amit Prakash. All right. Um, yeah, as you can see here, these dudes are pretty remarkably accomplished. And overall, they've put together an absolutely amazing resource. So, what I'd like to bring to you today would be the ability to work through this book on YouTube, right? I think some of us learn best through videos, and I really think a book as good as this one really deserves uh, a platform like YouTube to be broadcasted over. All right. This is just the table of contents. Please buy the book from the publishers. I've done the same. This is just a PDF version so that I can share it with you. All right. Let's get into this. Uh, so, Elements of Programming Interviews aims to help engineers interview for software development position. The primary focus of EPI is data structures, algorithms, system design, and problem solving. The material is largely presented through questions. An interview problem. Let's begin with figure 1 below. It depicts movements in the share price of a company over 40 days. Specifically for each day, the chart shows the daily high and low and the price at the opening bell, denoted by the white square. Suppose you are asked in an interview to design an algorithm that determines the maximum profit that could have been made by buying and then selling the single share over a single given day range, subject to the constraint that the buy and sell have to take place at the start of the day. This algorithm may be needed to backtest a trading strategy. You may want to stop reading now and attempt this problem on your own. Yeah, I'd recommend doing that. Um, just to sort of give you an idea of setting limitations and setting your assumptions. All right, when you're done with that, first clarify the problem. Um, for example, you should ask for the input format. Let's say the input consists of three arrays, L, H, and S, of non-negative floating point numbers representing the low, high, and starting prices for each day. The constraint that the purchase and sale have to take place at the start of the day means that it suffices to consider S. You may be tempted to simply return the difference of the minimum and maximum elements in S. If you try a few test cases, you will see that the minimum can occur after the maximum, which violates the requirements in the problem statement. You have to buy before you can sell. I mean, that makes sense, right? You would have to buy before you can sell. At this point, a brute force algorithm would be appropriate. So, a brute force algorithm, for the people who do know, please bear with me. This is meant to be sort of a baseline up approach. Uh, at this point, a brute force algorithm would be appropriate. So, a brute force algorithm basically is an algorithm that lets you, would be your most obvious solution, right? Let's say like if you had a wall, if you didn't know a wall was really hard to break through, you would try and run through it. And a brute force algorithm would work for you because you'd be a brute applying force, and if you were a strong enough brute, your solution would work. So I'm assuming that's where the name comes from, or yeah, probably. For each pair of indices I and j is greater than 1, if okay, so for each pair of indices I and j, right? So I would assume the I here is for the lower prices and j is for the high prices. So j, if s of j minus s of I, So that's the difference between the high and low prices for that particular day is greater than the largest difference seen so far. So you'd essentially be going through all of them and comparing their differences. And if it's the highest seen so far, update the largest difference to S of j minus S of I. So you'd essentially have to keep track of what the largest difference is and compare it along. And there was a solution, if there was a difference that was larger than your already anticipated, already calculated difference, you would replace it. You should be able to code this algorithm using a pair of nested for loops and test it in a matter of a few minutes. Um, yeah, that's basically true. There's a certain way to go through this, um, as in nesting for loops so that you compare every element. Um, if you can think of how to do a selection sort off the top of your head, that's probably exactly the same sort of principle of comparing every element. I don't know why I'm saying this. It's just something with for loops that is for loops and arrays, I guess, that is extremely useful, right? It's using your iterator in a way that you probably would not use normally if I don't know. It's not super intuitive unless you're familiar with it. Um, you should also derive its time complexity as a function of the length n of the input array. The outer loop is invoked n minus one times, and the ith iteration processes n minus one minus I elements. Right. So this is basically what I'm saying. Right. It's kind of weird to listen to, but it's honestly not super hard. Let me see if I can pull up a solution here of something similar. All right, yeah. So let's see if let me just cut that portion out. All right. Uh, no, that did not. All right. So here we have um, an array. We have two iterable arrays where it sort of demonstrates this particular comparison, right? You have for I in range length A. So that would iterate through all the indices of a particular array. The Okay, so the way a range function works is it returns an iterable of um, the argument that's passed to it. So range isn't actually a list; it's something that you can iterate through. Um, okay, that's one thing, and also range is kind of cool in that it starts with if if you give it no initial parameter, it starts with 0. So if I were to do range of 5, I wouldn't get 1, 2, 3, 4, 5. I would get 0, 1, 2, 3, 4, which makes it perfect for working with arrays, zero index arrays, which Python uses. Um, for j in range I plus 1, um, so this is where it gets kind of strange, right? Obviously, uh, you'd have to have how do you say two indices for this kind of iteration to even exist. Uh, so what this allows you to do is go through all of your elements in the array, and in the same array, you basically would compare each element to another element that is not the same as it. All right. I don't think I'm doing a great job explaining this, but I'm gonna try and print this out for you guys so that it makes a little more sense. So let's try and run this file in the console. Right. Okay. So there, this is what you sort of get. You get 0, 1, 0, 2, 0, 3, 0, 4, and then 1, 2, 1, 3, 1, 4. So it effectively runs through every element in the array and compares them without ever having a duplicate of that particular comparison. Super important, super useful, super basic. It's not immediately intuitive, but you will get there, and it is useful to know. All right, after that massive deviation, the outer loop is invoked n minus 1 times. Right, it is invoked n minus 1 times. And the iteration process is, and the ith iteration process is n minus 1 minus I elements. Processing an element entails computing a difference, performing a compare, and possibly updating a variable, all of which take constant time, right? So this is related to time complexity. Uh, Constant time is basically big O of 1. So hence the runtime is proportional to sigma I is equal to 0 to n minus 2 um, of n minus 1 minus I, which is equal to n minus 1 times n over 2. All right. That's your equation, I guess. Okay, wow, I really don't understand this problem. The time complexity of the brute force algorithm is big O of n squared. I can tell you how to get that at least. N minus 1 times n over 2 gives you n squared minus n over 2. And so for uh, time complexity, you can basically just take your largest polynomial and get rid of the rest, and that's basically what they've done there. You'd use two nested arrays, so you'd have to essentially do that, right? Like you'd have an n iteration of all the numbers, and you'd have an n iteration of all the lower numbers. I mean, higher prices and lower prices, and you'd get big O of n squared. You should also consider the space complexity, how much memory your algorithm uses. The array itself takes memory proportional to n, and the additional memory used by the brute force algorithm is a constant independent of n, a couple of iterators, and one floating point variable. Right, that's true. A couple of iterators are I and j here, and one floating point variable would be the variable that stores the highest price at the moment. Right. So let's consider this. What is this? What is this doing? Also, anything that I said regarding this doesn't really apply. It's not really true. It doesn't really apply here. So something super important to do, which I'm telling myself, is probably read the entire question first, and then don't rush to assumptions or conclusion, right? So hence the runtime is proportional to sigma n minus 2, I is equal to 0, n minus 1 minus I, which is equal to n minus 1. Right, so let's try and figure out what that's doing, right? Our equation is, let's see, def y thing, okay, right. So our equation is n minus 1 minus I. So let's put that into, right. So yeah, okay. So what the iterator does is it takes, I mean, that's summation operator. Oh yeah, that is a summation operator. It does a sum of everything of that particular equation. So it is a summation operator of Mm, I guess take an n. But so what it would do is for I in range length length of uh, a and then cut out the last two terms, I guess. And do n minus 1 yeah, you'd want to do something like that. And basically, it would go through that equation that many times, which is equal to n minus 1. So, I mean, we can test this. So let's get rid of our original example because that was unnecessary. Yeah, good thing I can edit all of this out. Oh man, I can edit all this out. Yeah, good, fun, great. Run file in Python console. Okay, all right. So I can do equation. Let's see, 5. Yeah, I need an A here. There you go. Okay, let's read the section, right? The outer loop is invoked n minus 1 times, and the ith iteration processes n minus 1 minus I elements. You should also consider the space complexity, how much memory your algorithm uses. Oh man, so let me try to figure this out. Mr. Forms, a test in a few minutes. You should also derive its time complexity as a function of the length n of the input array. Man, I'm actually pretty stressed that I can't fucking do this. This is annoying. Okay, alright. For each pair of indices I and j is greater than I, S of j minus. Of non-negative flow. This at the start of the game means that it suffices the return difference of the minimum and maximum elements in F so that the minimum can occur. Move to I before you can sell at this point. Each pair of indices I and j is greater than the largest difference seen so far. Update the largest difference. Okay, so I think what they're saying is at this point, I'm good for solving indices I and j is greater than I. If S of j minus S of I is greater than the largest difference seen so far, update the largest difference to S of j minus S of I. You should be able to code this algorithm using a pair of nested for loops and test it in a matter of a few minutes. Okay, this part I think I was right about, right? It was this. So essentially, only if the prices are higher, if the sell price is higher, uh, then you'd even need to consider it. This is I and j is greater than I. This is I. For each pair of indices I, what is I here? Okay. Let's try and understand the problem better. Uni attempted to simply return the difference of the minimum and maximum elements in S. Okay, so at this point, so which violates the requirement of the problem statement. You have to buy before you can sell, okay? Alright. Will be appropriate for each pair of indices I and j is greater than I if S or j, the largest difference seen so far, up to the largest. To be able to code this algorithm using a pair of nested for loops and test in a matter of a few minutes, you should also derive its complexity as outage is invoked n minus 1 times. Is that true? Okay, so if I have 50 elements, the outer loop is invoked 49 times. Is that true? Why is that not true? The ith iteration processes. Okay, right. I mean, yeah, so n minus 1 times because the first part of the loop isn't really a loop invocation. It's just a run and run. And the ith iteration process is n minus 1 minus I elements. So that means, and the ith iteration process is n minus 1 minus I elements. Processing element entails computing a difference, performing a compare and processes n minus 1 minus I elements. So n minus 1 is from the number of loops minus I elements. So since I would assume this is something related to that previous condition. For each pair of indices I and j is greater than I, S of j S of I is greater than the largest difference seen so far. Update the largest difference. S of j is greater than the largest. The iteration process is n minus 1 minus I elements. Processing an element entails computing a difference and possibly updating a variable, all of which take constant time. Hence, the runtime is proportional to sigma is equal to 0 to n minus 2 n minus 1 times n. The first algorithm is big O of n squared. I want to come back to this. I want to take a break and come back to this. I will.